All right, the growth mindset, math maniac, Panthers. Mr. Hoffman here. You like my new look? Oh, that's not me. That's Miss Cabana. Okay, so we've already identified prime numbers and composites. We've got a cool song for that. We've got to differentiate between factors and multiples. We're not doing that right now. As a matter of fact, we're doing that next week, I believe. So just hold off on that. Don't get too excited, but don't get disappointed either, because we will come to this. All right? Oh, I know you can't wait. Use prime factorization to solve a problem. We did that. So this is what we're going to do right now. We didn't really get to this. We're going to just focus on the GCF thing. And then next week, we're going to get more into the real world problem part of it. All right, let's just look at the GCF. What's GCF? GCF stands for the greatest show on earth. No, greatest factor, greatest common factor. There it is. The greatest. Here we go. Greatest common factor. Set in a number that has in common. Something that's common means, in this case, they mean same. Which ones are the same? This will hopefully make more sense in a few moments. Let's go. Do I say let's go too much? I just realized that. I think I'm getting annoying myself with that word, those two words. So am I a math teacher? I can count, right? Okay, greatest common factor, T-charts. Ooh, this is new. I've never saw this before until this year, and I'm digging it. So if you look for all the factors of 12, well, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Now list all the factors of 18. 1 times 18, 18, 2 times 9, 18, 3 times 6, 18. Now look at all of them together. Look at the ones that they have in common. They have a 1 in common, they have a 2 in common, they have a 3 in common, they have a 6 in common. They have a lot in common. But are these 12s and 4s and 18s and 9s deal breakers? No, no. I think they might be live happily ever after. It's a rom-com. I'm a rom-commie. I'm a commie. I'm a rom-commie. Speaking of commie. Does that, what is rom-com? Oh, that's comedy, rom-comedy. The greatest comedy factor, a factor of errors. This is definitely one of those. Okay, but anyway, 6 you can see is the greatest one, right? Which one's the least common factor? A 1. Do we ever look for least common factors? What would be the least common factor of 177? 1. How about 1,077? 1. How about 277 and 76 and 79 and 69, 77, 77, 2007.7? Well, you can't use points. We're not really getting that. But in whole numbers, by the way, this is all whole numbers, not decimals or fractions. 1. So really, least common factor is not useful to us at all. That's right? You agree? I thought you might. You're smart. You agree with me. Yeah. He's like, Mr. Hoffman, I could agree with you, but then we'd both be wrong. Don't ever say that to your wife or your mom or anybody else that has more power than you. Okay. So anyway, the greatest factor in a set of numbers is common. Let's go. Oh, so what is the greatest common factor using T-charts of 24 and 36? What are the things? And I'm going to go slow on this one, but the rest of this presentation is going to go by very quick. So you can always do 1, all right? Because we said 1 times 24 and 1 times 36. Now, I'm just going to cover up this 36 thing for a few moments because it's going to be distracting to me. Hold on, I'll be right back. That's so much better. Now I could focus on this 24 thing. So I did 1 times 24 is 24. 2 times something is 24. I just happen to know 2 times 12 is 24. 3 times something is 24. 3 times something is 24. 3 times 1 is 3. 3 times 2 is, see, 3, 6, 9, 12, 15, 18, 21, 24. Oh, I did that on my fingers and I got 7. 3 times 7 is 24. See, it's like this. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Let's see, 3, 6, 9, 12, 15, 18, 21, 24. There's the 24 right here. That one, this one. Let's see, how many is that? That's 1, 2, 3, 4, 5, 6. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's a good thing I did that. I made a mistake. 8. There we go. Let's continue. What about 4? Do you know your 4s? So you really got to know your multiples to get your factors. To get your factors, it helps to know your multiples. See, 4, 8, 4, 8, 12, 16, 20, 24. There it is. I can stop right there. How many is that? 1, 2, 3, 4, 5, 6. What about 5? No. 6. Oh, we just did 6. And what about 7? Yeah, I think 7 might work. Do you know your sevens? 7 times something is 24. See, um, I only know the happy birthday one, so I do know one of them, but I can't think of it. So I'm just going to do the happy birthday one right now from, just impromptu here, extemporaneously. That's a fancy word for impromptu, which is a fancy word for just doing it right now without really thinking about it. Like go, like hey, go right now. What do you got? What do you have right now? Right this second. Um, see, 7, 14, 21, 28, and oh wait. I think we skipped it. I don't think there's anything. 7, 14, 21, 28. No, 21 and 28. Yeah. Oh, doesn't work. What about 8? Oh, this is one of my favorites. Ready? You put your 8, 16, and your 24. Oh, and your 32, and your 40 all about. Your 48 and 56 and a 64, 72, 80. You put your 8, 16. Wait, we can do this again. How many was that? You put your 8, 16, and your 24. There it is. So 8 times 3 is 24. See? 1, a 2, a 3. I use my fingers, though. I don't usually use this. Okay. So we can put an 8 and a 3 in here. 8 and a 3. Oh, we already did 8 and 3. Oh my gosh. What about 9? 9 times, no, because 9 times 3 is 27, and 9 times, so that's too big. Too big, too large, too big, too high. And 9 times 2 is 18, too small. Goldilocks is not digging this at all. Oh, I know where that came from. Okay, that's weird. What about, let's see, 9, 10, nope, 11, nope, because 11, nope, that's a prime number. Because 11, the only factors, oh no, we're doing multiples. Wait a second, multiples of 1 times, yeah, it's still not going to work because 11 times 2 is 22. Okay, 12, oh yeah, I just happen to know that one. 12, 24, 36, 48, 60, 72, 84. Tell you what, these songs come in handy, and it's way more fun than trying to memorize things, I think. Well, I did memorize things in a song. Let's see. So, oh, there's not, I'm gonna have to use a different color for it to pop out here. So we said, what we say, 12, and then we say, the other one was 2. Now, notice we're at the halfway point. Whenever you get half of the number, you're done. There's nothing else, right? 13, 40, it just doesn't work because you already did, you covered it. As long as you didn't miss anything, you got it. So now let's try the other side. 36. Ooh, okay. I'm gonna go a little bit faster here because I think 1 and 36. 2 times 15, 16, 18. And then 3 times, see, I'm thinking in my head. This is what I'm doing in my head right now. I'm going, oh, 3 goes into 3 once. 3 goes into 6 2 times, so it's 12. What about 4? I just happen to know 4 times 9, and I've got a really cool 9s trick too for you with your hands. You might know it if you don't know it. I can't wait to show you. It's one of the coolest things ever in math. What about 5? Nope. 6? Yeah, 6 times 6. Yeah, 5 doesn't have anything. 7? See, 7 times 6. 7 times 7 is 49. 7 times 6 is 42. 7, wait, we're doing 7 times 4 is 20. 7 times 4 is 28. 7 times 5 is 35. Nope. 8. 8 and 8 is 16. 16 is 32. Nope. 9. Oh yeah, there it is, 9. We did 9, remember? Right here. 9 and 4. What about 10? No. 11? No. 12? I don't know. Does 12 go into 36? What's 12 times, say, 3, for example? It's 36. Oh my gosh. Okay, that counts. So I'm running out of room, so I'm gonna have to, put it here. 12 and 36. Okay, what else? 12, 13. No, 14. I don't think so. 15, 16. By the way, if you notice any of the numbers that I'm saying, if they're not over here, like 16, for example, it doesn't really, even if it does have 16, I don't have 16 over here, so it's not going to help me. So I really like 17, no, 18. We already got 18 right there. 19, 20. Have we gotten halfway to 36 yet? What is half of 36? What is 36 divided by 2? That'll give us half of 36. If you have 36, you're going to split it in half. What two numbers would we have add together to get 36? Or you can go like this, 36 divided by 2. Oh, that is sloppy. So I'm going to clean this up. I'm just going to do the long division way because that seems like the easiest way for me. 36 divided by 2, still sloppy. Okay, 2 goes into 3 one time. 1 times 2 is 2. Subtract. 3 minus 2 is 1. Drop down the 6. How many times does 2 go into 16? Whatever that answer is, we put it here. 2 goes into 16. Well, 2 times something is 16. That's going to be an 8. So 8 goes up here. Now we got to multiply and make sure we don't have a remainder, which I know we don't. I can tell already. But anyway, 8. Oh, let's erase this too so we don't get too confused. 8 times 2. 8 times 2 is 16. And subtract, no remainder. So 2 times 18 is 36. I'm going to put that here. 2 and 18. Let's clean this up. And then what about, so there's 18. Well, that would have been 18 and 2. Oh my gosh, did I already have that? 19, 20. Am I halfway there yet? Oh, that's halfway there. That's what that was about. We already got, see, when you get halfway there, but you have to get halfway there on this side, all right? Because you might miss something otherwise. So now we did because it would have been 18 and 2. So we're done. Now we can look at and see what they have in common. And that's so messy. I'm going to go to the next page. Here's the next page, and let's see what they have in common. This is what they have in common. And what's the greatest one in common? Is the 12. Okay, this is a tough one, and I'm going to fly through it because this is becoming a long video. 12 minutes already, way too long. Okay, 1, 60, 2, 30, 3. I'm just going to let the slides speak for themselves. I'll let it pause on each slide because I'm talking too much. Oh, did you guys catch that right here? You see what I just did? I did extra work in a way. See, did you catch it? 12 times something is 60. We already had it up here. Silly me. Are you noticing something? Can we tell that 14 is not going to work without even trying it because it's not in here? Can we tell that 13, 14 is both of those aren't going to work because it's not here? And that, well, 15 will? Here it is. I wonder if that means 16, 17, 18, and 19 will not work because it's not in here. I never noticed that before. But anyway, this is one of my strategies for doing, well, 15 times something is 60. I like to take all the digits that are possible because it's going to be a single digit number. I know that much because if you go like this, if you go 15 into 60, 15 does not go in to just 6, right? It has to go into all of it, which means you will have to have a single digit because nothing goes into the tens place. It'll have to go into one digit goes into the ones place. A ones, a one. Which one though? Which one is it? We have a choice between 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what I call the middle strategy or the center strategy. Actually, I don't have a name for it. Maybe you can help me come up with a name for it. And I stole it from a student last year, but I love it whenever you're not sure what to put. Now you can take a guess. If you have a pretty good guess of what to put between 1 through 9, do that. But if you don't know, start with 5. Always start with 5. Start with 5. The 5 strategy. No, I don't know. We'll think of something eventually. So start with 5 because the reason why is because if 5 yields you an answer here that is too small, then you know you have to pick one of these bigger numbers. If this answer is too big, you know you have to pick one of these smaller numbers. Follow along. I think you'll catch on what I mean, okay? Aha, that's too high. So if 5 as a factor, if the factor 5, right, gives us a product that is too high, then we have to pick a lower factor that gives us a product that is lower. Make sense? Okay, let's see what I mean. See what I mean? Watch. Too high. So let's pick a lower one. Well, I'm just going to go with 4. I mean, you could pick a different one if you want, but I feel like 4. Use your intuition. This is where intuition comes into play. And of course, the more you do this, the more accurate and quicker you'll be able to identify which of these ones will probably be the best one to work. You'll become a factoring ninja master. Let's try a lower number. What do you know? Hey! So I'm cleaning things up over here because we didn't need all these ones that don't work. Didn't really even need to write these to begin with, but I just did it to kind of show you where I was going, where my thinking is. So you can see my thinking on the screen. Now, what about these? Remember what we said? Between 15 and 20, 16, 17, 18, and 19? Well, we know 20 works. So here I am doing extra work again. But I bet you these aren't going to work. Probably don't even need to try them. Let's see. Yep, I already tried them. They don't work. 60 though? Well, we already tried this too. But since I went ahead and showed you the disappear zero trick just for fun, I want to check it out. How fun this is. 20 times something is 60. Well, that's big numbers. I don't know that. That's intimidating. Oh yeah, you do. Watch this. Ready? Abracadabra. Disappear the zeros. Then, what's 2 times 3? It's 6. Oh, I'm sorry. 2 times something is 6. You know that that's a 3. Now, reappear the zeros. Nothing up my sleeve, and presto, there it is. 20 times 3 is 6. Of course, we already knew that, didn't we? 60, I'm sorry. 20 times 3 is 60. There it is. Did it twice. Did it twice. Didn't need to do all that work. So you're like, Mr. Hoffman, this is too much work. Well, if you are a little bit more smarter than me, it won't be as much work. See, so they say work harder. No, work smarter. Sometimes you got to work smarter and not have to do all this stuff. Okay, but anyway, since I did it, what about between 21 and 30? See, here we go again. I went and did all this stuff. Well, you think you might have to, but guess what? You don't, because you can see between 20 and 30, none of them are going to work. 21, 22, 23, 24, 25, 26, 27, 28, none of them will work. And of course, nope, 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 not a whole number anyway. Nope. But when you get to here, it works. Well, we already did it again, but for fun, disappear zero. 30 times something is 60. I don't know that. Oh yeah, do you know what 3 times something is 6? Yeah, 3 times 2 is 6. So put the 2 in there, put the zeros back on, and 30 times 2 is 60. Oh, so much craziness. Now here's that halfway point. Remember, we should probably have done that to begin with. What's half of 60? 30. And as soon as you get the 30 on this side, because we had the 30 on this side a long time ago. So if we would have said, oh, we're done. No, because if we would have said that back then there, once upon a time, we would have missed all these factors down here, right? But we kept going. So once the 30 shows up on this side, then we're done. I got 90 over here. I already did 15. What's half of 90? What's half of 90? 90, 90, 90 divided by 2 is, or you could say 2 times something is 90, or you could do it this way, 90 divided by 2 is, well, 2 goes into 9 4 times. 4 times 2 is 8. Subtract. 1, bring down the 0. Aha, how many times does 2 go into 10? 5 times. So half of 90 is 45. And as you can see, we got the 45 here. But remember, it has to be on this side before we're done. So let's see. What about 30? Does 30 work? We already did 30. Yeah. But 90? Wait a second. I just realized 45. Is 45 one of the numbers over here? It's not. So we don't even need to worry about it. It's not going to help. Even if 45 was a factor of 90, which it is because it's 2. Oh, it's right here. It doesn't help us because there's no 45s over here. So the one that's going to help us, I think, is this one. 9, 10, because we know 10 times 9, 11, 12, so on and so forth. Yeah. I mean, we don't need to do 12 because as soon as we see 30, as a matter of fact, as soon as we see 30 here and we know that there's a 30 here, I don't think we had to do any of these because they're not going to help us. I don't. Well, then again, their opposite side might. The side, whatever's on this side could, maybe. So yeah, I guess we did have to do those. Hey, I'm just thinking here, okay? "Hey, you're a teacher, don't you know what you're doing?" Well, yeah, of course I do, but I'm also like I'm always trying to find faster, better, improve ways. You can always try to learn more, right? There's always ways you can get better and faster. I mean, come on. Do you think LeBron James or any great person who's good at what they do just stops whenever they think they're like, I'm good enough. I'm the greatest. I don't have to get greater. No, they're always like, wait a minute. I bet you there's a way to get better. All right, fly through these slides. Okay. There's a video there if you want to watch it. Here's a nice little anchor chart for you. Now here's the fun fact. Can you figure out what the fun fact is? Look at this. What's the fun fact? What do you notice? Factors of 2 and 3. The greatest common factor of 2 and 3 is 1. Factors of 5 and 7. Ooh. The greatest common factor of 5 and 7 is 1. Ooh, what's the fun fact? Factors of 11, 13. Have you gotten it yet? Does that sound familiar? I can't even remember my own song that I wrote about these things that only have factors of 1 and itself, 1 in itself. Put them together, 1, 1 in itself, 1 in itself. What are those things called? 1 in itself? That have factors of just 1 in itself? I know it starts with a P. I know that. P. The first something, the first 5 something. What are the first 5? 1, 2, 3. 1, 2, 3. 5, 7, 1, 2, 3, 5, 7. If you want to take it up to the next level, turn it all the way up to 11. Oh, look, there's a 2, there's a 3. 2, 3, 5, 7, 11. And yeah, these are all that PRIME prime numbers. So the greatest common factor of two prime numbers, it could be more than two, it could be like a million prime numbers, is it's always going to be bum 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 da dum bum 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 one prime, Optimus Prime. Do you ever look up what prime means? I'm gonna have to look it up in a dictionary. I bet you it has something to do with the number one. I bet. Like primary, my primary means, that's my number one means of doing something. Prime, I'm pretty sure it means one. Okay, ready? Ooh, I should have said try to do this first. Then come back. Pretend like that didn't happen. Try to solve this problem and pause the video. I encourage you to pause the video and then come back and see how you did. Ready? Okay, let's see how you did. Yay, good job. You remember the rainbow? Yeah, the rainbow, there it is. You're like, how did you come up with that? 1 times 12, 2 times 6, 3 times 4, all equals 12. 1 times 16, 2 times 8, 4 times 4, all equals 16. Okay, please pause the video. I encourage you to. It'll bring good karma to you if you pause the video and at least try this for at least 2 minutes. Oh, did you do it for at least 2 minutes? Oh, you spent 10 minutes on it. Wow, I'm impressed. Okay, let's see how you did. Did you make a rainbow? Isn't that beautiful? So which one's the greatest? I think it's 6, all right? So 6 would be the answer for this one, I'm pretty sure. So the greatest common factor. Now here's the factors of 36. Here's the factors of 66, but the greatest common one is 6. Yeah? Yeah. Please pause the video and try this. Oh, you're back already? Let's see how you did. Oh, and speaking of video, here's a video that in the PowerPoint, which I'll be posting in OMHS for your viewing pleasure. And you may want to dance to it as well. You may dine to it. You might decide to have a snack while you're watching this video. Maybe you can figure out the greatest common factor between how many Oreos you have and how many, let's say you have some Doritos. Lay some out. Lay out a handful of Doritos, lay out a few Oreos, and figure out the greatest common factor. It's fun times. Okay, let's see what you know. You don't have a polling tool. This was originally in the lesson. This is extra bonus material in a way. Did you get this for 18 and this for 24? You factoring ninja, you're so good at chopping these numbers down into little tiny numbers. Chopping these numbers, factoring them into little tiny numbers. Factor, say factor, height, ninja. Chop it with your samurai sword. Would that be a samurai warrior? Do ninjas have samurai swords? I'm not sure what kind of swords they have, but it's what they got. Okay. Try this one, please. I said try this one. Pause the video. I said pause the video. You still haven't paused it. You're a difficult one, aren't you? Yeah, if you're not, you're obviously not that difficult because you wouldn't still be here listening to this video if you were difficult. So I take it back completely. Okay. Oh, see, I even put some of my work up here because I wasn't sure if 3 and 54, where was that at, right? 3 and 8. See, I wasn't sure if 3 would have be a factor of 54, so I just divided 54 by 3 and I got 18. I said, oh, it works. Okay, Factor Ninja. Can you find the greatest common factor of two whole numbers, which is our target? for example, 20 and 30. Can you do it? I bet you can do this one. What are the factors of 20? What are the factors of 30? Let's see. Let's start with 20. Factor Ninja! Hi, chop, 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 chop. Chopped it down into these numbers. And, ready? Now we must Factor Ninja! Chop, 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 chop. Whoosh! Hi. These numbers. Which of these smaller pieces are the same size? Do you see what I mean by that? Which of these smaller pieces here in yellow and the smaller pieces in blue are the same size? Which yellow ones are the same size as those ones in blue? Aha! We found that 1's the same size, 2's the same size, 5's the same size, and 10's are the same size. No more. Hi! 1, 2, 5, and 10. Factor Ninja. Which of these common smaller pieces are the biggest? So out of all these pieces that are in common, which ones are the biggest? Well, it's not 1's, it's not 2's, it's not 5's. The biggest ones are the 10's. Hi! 10. 8. 10 is the greatest common factor of 20 and 30. Try this one. Factors of 50 and 100. And you know we have to pause the video because I'm going to be revealing the answer. If you don't pause the video, you're just going to see the answer before you work, and that's not exactly cheating, but it's not really doing the work either. Because sometimes you have to work hard. I said work smarter, but sometimes you have to work harder. I don't know which time this is. Here's the rainbow. 1 times 50, 2 times 25. What about 3? No. What about 4? No. 5 times 10. Okay, I think that's it, right, for 50? Oh, I didn't get to half. Oh, I did get to half. I don't know. Anyway, I'm not following my own rules. Shame on me. No shame. Shame's not good. Guilt? Yes, maybe. Tired, end of the day. It's 5 o'clock on a Friday. I need to get done. Yes. I think it's good enough, right? Oh, I love blue and the rainbow. There it is, 50. Oh, you think this is going to be, this is what I noticed. When I first saw this, I was like, I'm so done with this. Do I got to do more of these examples? Then I realized the person who wrote this, who is I think it's Mrs. actually, Cabana, she did this. And I'm like, oh, now I know why she did this, because she's like, we got to do more work. Guess what? If you know a few things about primes, you know that these are both prime numbers, and you know the fun fact that we did way back yonder about 20 hours, 20 minutes, 20 years ago. Way about, see your life flash before your eyes here? Here it is. We know that the greatest common factor of two prime numbers or more is always 1. And so then I realized, oh, that's where she's going with this here. She's like, Factor Ninja height. Factor Ninja chops things into smaller pieces. Let's chop these 50 into smaller pieces. Oh, we did that already. We're trying to get to the one this one. See? 1 and 41. What are the common factors? There's only one common factor. What's the greatest common factor? Well, the only one that you have. Oh no. Prime. So remember, anytime you see any of these numbers, 2, 3, 5. Wait, I thought 4. 1, 2, 3. Oh, that's right. The song goes 1, 2, 3. 1, 2, 3. 5, 7. I can't remember my own song, but I do know the next number is 11. All right. So anyway, let's see what else we got. Oh, look, 11. See? Done. Guess what? She tricked us again because 22. Guess what? Do you see 22 here? It's not a prime number. I'm like, darn it, Miss Cabana, you got me. I went too quick because I thought I saw a pattern and I was going with the pattern. And so, oh, there's a pattern. She wants us to do another prime. So no, because there is 1 times 22, but there's one other number. Well, what's half of 22? When you get to that point, you're done. Guess what? Yeah, it's 11. It's 11. Yeah, so now we know it's 11. You sneaky. And that's the whole thing. If you stuck around for this, you have to say, give me the password, and I owe you like something. I owe you. I don't know what I'm going to owe you, but I owe you. If you've gotten through this lesson, 34 minutes, just say, Mr. Hoffman, you owe me a panda. That's the cut. I'm not going to be able to give you a panda, but just say that, and then I'll know what you mean, and then we'll have to owe you something. I'm not sure what. We'll figure it out. Bye.